In this video, we're going to take a look at the lowest common multiple. So the LCM, or the lowest common multiple, is the lowest quantity that is a multiple of two or more numbers. And we have two methods in particular that we can use to find the LCM. The first method here, method 1, is to list the multiples of these numbers here that we're looking to find the LCM of. So let's just write this down here. So method 1 is to list the multiples and then for method 2 here, this is using prime factors. So using prime factors. So let's take a look at both of these methods here now. Let's say that we want to find the LCM of 12 and 20. Okay, so find the LCM, the lowest common multiple of 12 and 20. Okay. So for method 1 here, what we're going to do is we're going to list the multiples of 12, list the multiples of 20 then, and from there we can identify the lowest common multiple. So multiples of 12 here. So it's up to you how many multiples you kind of list here to begin with. What I recommend is just listing the first 5 multiples to begin with. So for the multiples of 12 then, we've got 12, 24, 36, 48, and 60. And then for the multiples of 20 here, again, just listing the first 5 multiples now of 20. Then we'd start with 20 here, 40, 60, 80, and 100 here. So basically what we're looking for is the first number that occurs in both lists here, or appears in both lists. And in this case here, I notice I've got a 60 here in my multiples of 12. I've got a 60 here in the multiples of 20. That's the first number that occurs in both lists here. So in that case then, so therefore, the LCM, the lowest common multiple of 12 and 20, is equal to 60. Okay, so that's the first method there, that's listing the multiples. Let's take a look now at method 2 here of using prime factors. What we're going to do here is do our prime factor trees for 12 and 20. And what I'll do here is I'll just do it in a different color. Let's just split these two methods off here. Like so. So method 2 then, using prime factors, like I said, we just want the prime factor trees now for 12 and 20. Identify all the prime factors then for 12 and 20. So for 12 here, I do 2 and 6. 2 is a prime number, so we circle 2. 6 obviously isn't prime, so we do 2 more branches here. And I get 2 and 3, which are both prime. We circle both of these numbers here. Taking a look now at 20 here. So 2 more branches from 20. I'm going to do 2 and 10. Obviously 2 is a prime number, so we circle 2. 2 more branches now from 10 because 10 is not prime. I get 2 and 5, both of which are prime. So we circle both of those. What we've got here now is the prime factors for 12 and 20. So what I'm going to do now is write 12 and 20 as a product of their prime factors. So 12 here, that's equal to 2 times 2 times 3. So 2 times 2 times 3. And then for 20 here, we've got 2 times 2 times 5. 2 times 2 times 5. When we're using method 2 here now for the lowest common multiple, the LCM, what we do now is we just multiply all the prime factors here for 12 and 20, but we have to be slightly careful. So for the LCM here, So for the LCM of 12 and 20, And like we said, we just multiply the prime factors together. But what we need to be careful of here is if it occurs twice, so for example, these twos here that are matching up, then I only multiply that once together, if that makes sense. So what I mean by that is we only take one of these twos here. I've got two. I've got two twos here. So again, I only take one of those twos. So it's going to be 2 times 2. And then for this final column here of 3 and 5, well, obviously that's not the same in both lists here. We take both of those. So it's going to be 2 times 2 times the 3 here and times it by the 5 as well. Okay. Well, 2 times 2 is 4. Then we times that by 3. So 4 times by 3 times by 5. Well, 4 times 3 is 12. I get 12 times by 5. And 12 times by 5 would give us 60 there. Okay. And obviously that shouldn't be a surprise that we get the exact same LCM here. It's just a different method of finding the LCM. Okay. But there we have it. So those are the two methods there that we can use to find the lowest common multiple. What I would recommend here that you use method 2. It might seem a little bit longer here when, for example, you can find the LCM quite quick here with just this, this method here listing the multiples. What you'll see in a moment is method 2 is better when the LCM is quite a large number. Okay, so that brings the end of this introduction here for the lowest common multiple, the LCM. What we're going to do now is just take a look at a practice question. So we just take a look now at this practice question here, where we're asked to find the LCM or the lowest common multiple for the following numbers. We've got two parts here, so let's begin with the first part. The two numbers here are 8 and 30. So 8 and 30 here. So the lowest common multiple here of 8 and 30. Well, like we just saw then on the introduction here, I'm using method 2 of prime factors. So what I'm going to do now is list the prime factors here of 8, list the prime factors of 30, and then we can easily find the LCM. So we start here with the prime factor trees for 8 and 30. So let's start off with 8. Well, I can write this here as 2 and 4, where 2 is a prime number. 4 isn't a prime number, but we can write that as 2 and 2, where 2 is a prime number. And there we have it. So that's the prime factorization there for 8. Repeating this now for 30 here. So 2 branches here. I can write this as 3 and 10. 3 is a prime number, so we circle 3. 2 branches now from 10, because 10 is not a prime number. I'm going to get 2 and 5 here, both of which are prime, so we circle these numbers. So what we've got now is the prime factors here of 8, the prime factors of 30. So what I'm going to do now, write this as a product. So 8 then, that's 2 times 2 times 2. 2 times 2 times 2. And then for 30 here, right, this is 2 times 3 times 5. So 2 times 3 times 5. So we've got the prime factors here now. So remember to find the lowest common multiple here, the LCM. So therefore, the LCM of 8 and 30 here. Well, like we said, we just multiplied the prime factors together now. But what we need to do here is match them, which we've already done. So basically, you've got a 2 here in the prime factors for 8. Any 2s here for the prime factors of 30. You need to match those in a column. Okay, like you can see, we did that here. Now, if you have more than one in a column like we've got here, we've got 2 2s in this column, then we only take one of those for our product. Okay, so we only take one of these 2s here. I've got 2. So moving on to the next column now, I've got 2 and 3 here. They're different numbers, so we take both of those numbers here in our product. So we take this now as 2 here. We times that by 3 as well. And moving on to my last column here, we've got a 2 and a 5 again. They're both different numbers, so we take both of those numbers for our product now. We've got 2 times 2 times 3. And for the last column here, we've got 2 and 5. So times it by 2 and times it by 5. So now if we evaluate this product here, 2 times 2 is 4. Times it by 2 again would give us 8. I've got 8 times 3 times 5. Well, 8 times 3 is 24. Times it by 5. And we get 120 there. Okay. In that case then, the lowest common multiple here of 8 and 30 is 120. That's the solution to part A. Let's take a look at B now. And what I'm going to do here, I'm just going to clear the screen, just so I've got enough room to do B as well. So moving on to B now, where we've got 21 and 40. So again, just using method 2 here for prime factors. So now, I need the prime factors here for 21. Well, I can write this here as 3 and 7. Nice and straightforward because both of these numbers here are prime. That's the prime factorization for 21 complete already. Moving on to 40 now. In my two branches here, so if I write this here as 4 and 10, well, neither of these numbers here are prime, so we do two branches from each of these numbers, like so. So 4 here, I can write that as 2 and 2, where 2 is a prime number, so we circle that. And then for 10 here, I'm going to write that as 2 and 5, which both of those are also prime. So now what we found here is the prime factorization for 21 and 40. So now if we write this here as a product, 21 would be equal to 3 times 7. And then for 40 here, again just writing this as a product, now we've got 2 times 2 times 2 times 5. And what you'll immediately notice here, hopefully anyway, is that for the prime factors, none of these are common now between both of these numbers. So the prime factor for 21 are different to the prime factor of 40 here. There's no number that's common to both lists. So in this case then, the LCM, the lowest common multiple of 21 and 40, and in this case here, it would just be the product of all of these numbers here. Okay, because we don't need to worry about any number occurring twice in either of these columns here. It's going to be 2 times 2 times 2 times by 3 times by 5 times by 7. If we're doing it in order anyway, obviously the order of multiplication doesn't matter, but just so we can make it look a little bit neater here, we've got 2 times 2 times 2 times that by 3 times that by 5, and then we times that by 7. So we just simplify this here. Obviously, if this was on a calculator paper, you could just put this into your calculator. If we're doing it by hand, well, I've got 2 times 2 times 2, so that's 2 cubed, which is 8. We then times that by 3, times that by 5, and times that by 7. Well, 8 times 3 is 24. 8 times 3 is 24. Times that by 5, times that by 7. Well, 24 times 5 is 120. We've got 120 times 7, and 120 times 7 here. Well, it's up to you whether you do this as column multiplication, or what I'm going to do here is think about 120 times 5. That would give me 600, and plus a 240 then from 120 times 2. I'm going to get 840 there. Okay? We get 840 there, the lowest common multiple of 21 and 40. And there we have it, so that's the solution for part B there. And that's why I said use method 2 here of prime factors, because like you can see for part B then, if you were to list the multiples here of 21 and 40, you'd be going for quite a while until you got this number here of 840. Okay, so that's why method 2 there, using the prime factors, is just that little bit better. But there we have it, so that's the solution to A that we got previously, and then the solution to B there of 840. And there we have it, so that brings the end of this video on finding the lowest common multiple.